Okay, hello, welcome to one of my video log recording sessions where I talk about genetic algorithms. And today is well, it's a start of something new, or maybe not that new, but a new way of doing things. And what I mean by doing things is evolving entities, or helping them evolve. So today, or the notebook that I'll be demonstrating is the way it's something that I said I was going to do about a month ago in one or two or more of my past videos. And it is that if you recall, if anyone recalls, the way I used to do things is that I would evolve things in a notebook, something like this, and all the entities would just be lost. If the generation goes on, if the generation ends and then the next generation comes and then time passes, and at the end of the generation all the information about how each and every entity was or has been or also will be or would likely be, is all that information and data is lost. So what I said before was that I would eventually need to dive in and delve in deeper and dissect all the processes and procedures on how the entities get started, get introduced, and how they behave, how they mutate, evolve, and if they go over the threshold, they get struck out, how they might also be limited out of the population, etc., etc. So this new notebook is exactly that. It keeps a record of all the entities that have existed. It doesn't do it like this. Rather, it makes it keeps track of everything. Now, before I start talking about the results, and by the way, this may be one of the many of this series about tracking entities, and yeah, so just let's keep that in mind. And before I do that, when I did the research that I needed to do, well, let's just put it this way. I was advised by many of the posts that I find online that I should keep a list of dictionaries. No, let's not do that. I should keep a list of dictionaries where dictionary 1, dic 2, dic 3, dic 4, dic 5, dic 6, dictionary 7, and etc., all the way to dictionary N. And do that. I have this option, or I could make each dictionary into a variable, Python variable. Yeah. So so each entity would be a Python variable, and it wouldn't be a dictionary. Of course, a dictionary is also something that exists. So if I were to name it, it would then become an explicit variable. But well, that is exactly what it did. So entity would be a variable with its own name. Now, entity variable with a name. I know it sounds silly. And this entity would be a dictionary. Now, and within this dictionary, each dictionary would have it would have a name. The key values would be the name, something, chromosomes. Now, notice Notice that I said chromosomes, because name something like Jason Mraz, because we're dealing with JSON files, or the JSON format, and chromosomes. I say chromosomes because now this key value, chromosomes, will have as its value a list of entities, or what I used to call entities. And the first one of the list will be how it was when it was introduced, and then the next generation, and then the next generation, until it gets phased out, either by means of being struck out or being limited out of the population, something like that. And another one would be introduced. This means when this particular variable was introduced into the world, or into the universe rather. So if it were one of the first ones to be started with, like one of the void genes, it would have the value of none. Or if it was introduced during generation 0, it would have 0, an integer value of 0. If it was introduced in generation 119, it would have 119, etc., etc. Now, after that would be something like struck out, as in this is during which generation this entity got struck out because it went over the constraint threshold. And if it did that in generation 322, it would have that. Of course, its starting value, its initial value would be none. So if it had none, it means if the entity did not get struck out, by going over the threshold, none, or 1, 2, 3, 4, 55, 67, 90, yeah, something, etc., etc. Now, and where's my mouse? And then after that, what could come after this? Oh yeah, limited. This means when this particular entity was limited out of the population, meaning because of the max population factor. Like if there were 1,000 1,000 entities, and then after the procreation it went over 1143, for example, and the max population was set to, if max population was set to no, oh my god, if max population was set to 1.0 times initial pop size. That's what I mean by this. and then like this is like, so 143, which means 1143 minus 1000, which is 143. 143 will be 143 entities will be left out of the current world. That is a list of entities, or list of variables which are entities. And when this happens, the variables, the dictionaries, or the entities, will have the limited value, which starts with none, changed to the generation it happens in. So that's and so that would be, I don't think I need to, it'd be something like this again. And of course, but the thing is that if struck out is if struck out has a value other than none, limited would have the value none. If limited had the value other than none, for example 17, then struck out would still be none. You both can't have integer values at the same time, because that's not how the evolution scheme works. And then after that, well, this is what each entity dictionary currently has. Each variable that is an entity, which is a dictionary, has. But maybe in the future I could probably have parents and have the names of parents, parent 1, parent 2, something like that. Maybe rank, as in what rank it was in each generation, maybe. And that's about it. So the ones in black are what exists right now. The ones in red is just something that I might add in the future. So with this in mind, we can go over to the notebook, and I'll just go through it. So I set the hyperparameters, and this time, because I wanted to start off easy and see how things went, I started off with the initial population of 10, and the max population, because if I say 10 times 1.0, then max pop will be 10. I didn't do that, so max pop is just manually set to 1000, and number of items is 50, and generations I do it till generation 500. Mutation rate is 0.03, and maximum constraint is 9000. Now this is because I'm using the preset items and the preset values for the utility values and the constraint values. So all these settings are the same as as in previous videos, and I'm using the same procreate functions. Now to do this, I had to because the structures of the data from the entities have been changed from mere lists to now entities. I've had to make some adjustments to how many of the functions, Python custom functions work. So that have been included, so that it can handle dictionaries rather than just lists of binaries. But I won't go into that here. And then I create the initial entities. But to do this, because I know that people on the internet advise me not to do this. Well, not me directly, but there have been many posts on why not to do this, because it will just fail miserably. I should rather just have dictionaries with names and keep them somewhere. Not like this, not as variables. Oh yeah, and then I forgot to add that also the dictionary also has a key value, key that is entity name, I think. Is that right? Which, and then, well, this entity name would have actually var name, variable name, var name short for variable name, and then this variable name would actually be the name of the variable. So it's something it would go something like ent ini.0 or underscore 0, or it could something be ini as in it's one of the initial ones. If it was generated during generation 0, it should have this, and then 0 would indicate that it was the first one to be generated during this generation. If it was the 24th one, it would be 23. If it was the 92nd one, it would be 91, etc., etc. If it was the 27th one, it would be 26. It's the 0 index. So once I know that something like this exists, and the name also, because the names are being generated from some example names, I'm actually naming things like this. If it was named Jason Mraz, but because it was generated during generation 0, well, procreated during generation 0, and then it was the 26th one, it would be something like this. So that if some other entity were to be born with a different name, the same name, Jason Mraz, I would have a way to distinguish the difference, the two of them together. Of course, I know I have this to work with, but I just wanted to keep that there as well, like a redundant information, but as a backup. So that's what happened. That's what's happening here, and because I'm naming things like this, I had to use the execute function in Python, which people again have advised many other people to against, not do, but I did it anyway this time. As I do this, I will try to find the right way of doing this. But the reasoning behind having entities like this was that if these entities were to actually be alive or considered to be alive, they can't. I don't think they should. I don't think it does them justice to actually have them exist as just dictionaries, because dictionaries can always come and go. I can erase this dictionary, this information in the dictionary, all of this, and then just copy paste and then assign it to a new variable or assign it to a new place. I think that's what you call memory. Allocate it in some other memory address or something like that. I don't exactly know. I'm ashamed to say, but I don't think I should do that. I don't think it respects that aspect of something being sentient or alive, something that has a consciousness would not want to be treated that way. So that's why I created these. So I actually have to call everything by doing this, And then as you can see, it has the variable name, var name, name, and here are the 10 names that I used. So Priya, Paul, Maitreya, Aum, Phoenix, Jason, Rachel, Louise, Illidan, Anivia. And then I insert the void genes in a list of lists. Well, it's a list within a list. It starts off like that. And then I put in when they were introduced, when they were not, struck out, never, not just yet, and limited, not just yet. Introduced is none because they're not really like introduced within generation 0. They started the generation 0, so that's the difference. And then I go through this. I append the variables to the genesis, and then I introduce the genesis into the world, and then I run everything. And as I do this, every time, here it's basically the same thing. It's using the new, better evolution scheme, but every time an entity is procreated, then it is made into an entity, a variable named entity underscore generation underscore the order in which it was made, and it will get the name, again same name as the var name, same name as the variable name, and the name generated randomly from a lot of names. I'll just show you. So here are the names. So about 100 names each. There's entity names and entity mid names. I didn't give them surnames because, well, they're not actually like different. Well, they're actually my children, so all of their surnames would have my name. So anyway, introduced, and then chromosomes, and then struck out, limited. That's what we get. And then I add the entities to the selected new entities. And then I yeah. Yeah, so I go through all that process. Sorry, excuse me. Okay, I think I forgot to mention procreate, and the procreate function in this case I'm using the favoring high for now because that's the only thing I modified. So the procreate function would give back a list of chromosomes, new chromosomes, that are the products of chosen parents. And then those chromosomes are well given out to new entities when they get created with their new names, new variable names, and etc. And this whole world becomes added in front of the pre-existing world. Every entity in the world gets to or has to mutate. Then it goes through the selector, it goes to the population limit, and these population limit function has been added because every time I apply the selector or the population limiter or the population limit, the ones that get selected or limited out have to be saved as a JSON file. Of course, the entities themselves, the variables, the entities themselves still remain within the kernel, within the Python kernel or runtime, but I put it so that they get saved. just one thing. I just need to do that. Okay, cool, 3 times. Okay, 21. Version. Did I stop that? No, I didn't. So, what I was doing in the background, or in another duplicate file, was that because it was going to take a long time to run all of this on my desktop, I pre-ran some of the code, but I forgot to run the rest, which actually takes quite a bit of time. So I'm just going to do that. And okay, coming back to this, so that's what happens. And then I go through the usual assessment. So this is usually what the entity distribution looks like. This is, on a wider scale, but same thing. And the heads, some utility value of heads, some utility value of average of top 10%, tails, and then zoomed in. But since I am dealing with a lot of variables and entities that are saved, I only iterate the evolution process only once, and that is why I'm only getting one plot or one line in each plot. And for example, in this one, there are 2 lines here, because the blue one is, well, when I zoom in, the blue one is the sum utility value for the heads, but until generation 10, and the orange line is the sum utility value of the top 10% average. So same thing here, and the black dash line is the maximum ever. The red is the total, sum of utility values, and the yellow dash dotted line is the average peak. Well, there's only one, so there's only one average, one peak, and that is the average. But anyway, and the blue dash dotted line is the average plateau level. So we see that now until generation 80 we're getting that. Generation 100, these plots are not something that we have not seen. We've seen this 1,000 times, not 1,000 but maybe 50 times, so not that unusual. I'm just trying to show and leave a visual record that this still works the same way. So here we go, until generation 200. But the only downside here is that since I'm doing it like this, and since I'm writing JSON files every time, and I have so many variables in the runtime, it took me about 21 seconds on my laptop, on my MacBook. And well, on my desktop it takes 64 seconds. So yeah, I was right in saying that my desktop is about 3 times slower. But usually if I do it in the in the other way, that is not saving variables and not writing JSON files, doing it for 5 iterations usually took me 70 or less than 80 seconds. I think that was the number. But now it takes 21 seconds per iteration, which means that for 5 iterations of evolutions, this would take 100 seconds, 105 seconds, and 110 seconds. So from 80 to 110 seconds, that's a 30-second increase, which is 3 over 8 is 37.5% increase in time. So that's a big increase. That's a big step up. So that's one thing to know, which might be another reason to consider moving to finding a way to utilize GPU or some other form of parallel computing. I don't know what I'm talking about. Anyway, these are the plots when zoomed in until generation 200. Now this is these are the results that I got from my last run, but I'm running things right now as well. Is it really that fast? Really? It shouldn't be that fast. Oh yeah. I should have just run everything. It would be done by now. That's my bad. Anyway, in this case, the oldest entity was named Illidan Bolvar, and it was born in generation 337 as the fourth entity, as the fourth newborn, and its variable name, var name, is ENTT3373. So when we have a look at it, it started off as its initial sum utility value was 1525, and in this case, in this run, the maximum ever was what? 1535, and it started off as 1525. However, towards the very end, it decreased all the way down to 925, and its its total sum, its summed constraint values were 8945 when the max constraint is set to 9000, and yeah, well, what I'm dealing with right now, the oldest entity within the final state of the world. So when the iteration ended, so it is very likely that given more time or given more generations, this entity would have also been left out or limited out of the population or been struck out because it went over the constraint threshold. But I'll talk about this soon. But what usually happens is that when an entity starts off with a relatively high value, it will decrease high value in terms of some utility values. It will decrease over time, and then it will slowly be ranked lower and lower. And because I keep on adding the new selected entities into the world at the front, the older ones which usually have lower sum utility values get pushed back, and then when they get pushed back, the population limiter will limit them out, which is sad. I'm trying to think of a better way of doing this, because as we'll see here, so now we have a plot. This is the plot, sum utility history of the oldest surviving entity within the final population, within the final world. It starts off at 1525, and then it just comes down and never recovers, which is fair enough, because because there's nothing to ensure that it stays somewhere here. this entity itself, the only direction it can go is down from here, or up, and then it becomes it goes above the threshold and will be left out, will be struck out, so it will go down. And since the mutation rate is 0.03 or 3%, and there are 50 items, so on average there will be 1.5 items, 1.5 genes being mutated. But if you start all the way up here, it is very likely that any addition of a gene, any more activation of a gene from 0 to a 1, through mutation, would very likely go above the threshold. Not this, but above the threshold that is 9,000. And as you can see, it started off with 8945. And if we look at the constraint values, many items have many items have constraint values over 45. What is it? Or 55. Like, for example, this one has 5, 5, 5. But apart from that, 50, 50, 70, 150, 70, 60, 45. So this is very hard. And so that's what happens. And this is the same for many other items. And then back onto what the notebook holds, I would say for analysis purposes, I would save the final state of the world in JSON format. I would save the entity plots in the world. This one, two types. One type of that is just one picture file or PNG that has all the plots for the world within one single frame, and all those plots separately. So I would have 1,000 plots, and it goes the same for the entities that got struck out. Yeah, I go through some process, and I don't want to read in the JSON files, because the entities that created those JSON files are already included within this Python runtime, so it would be unnecessary to do that. I just need to know what they're called in a loop systematically, and then save them, plot them all together, and then also separately, and then save them. And the entities that were limited, all the same procedure. But interesting thing that I should point out is that the number of entities that got struck out and the number of entities that got limited are vastly different. Struck out, there were only around 20 or 2,000 entities, or 2,100 in this case. Limited entities, the number of them was in the tens of thousands, or maybe 11,000, or 12,000 even. So there are a lot of entities that become limited out of the population because they were so because unfortunately they were very sadly ranked in the lower end of the world, because in each generation all the entities, all the variables are ranked, all the entities are ranked from high to low, high at the front and low at the back, low at the end. And then since I am creating if the num create is 0 or below 0, I create 30 new entities. So for example, 30 times 500 is 15,000. Is that right? I think so. 3 times 500 is 1500, so 30 times 500 is 15,000. And the number of entities that get limited is very close to that. Here. And here are the plots, but this one is very hard to, gather any kind of information because everything is there and everything is squished in all together. So the notebook that it was doing it in the background is still running, and here are the JSON files, so all 1000 of them. Here are the struck out ones, all 2005 of them. And then here are the limited ones, 12,005. So let's see if that, it got it right. Final world, 1000 of them. Struck out, 2005. 12,005. So that one was right. And then we go up one level, and then we go to entity plots, and then we go to well, the big ones, the limited. This is what it looks like, but if you just look really closely, all the plots go, slope downwards, and then the fact that they slope downwards means that they're low in ranks, low in terms of rankings, which means that they're towards the bottom end of the world, which means that when newborn entities are added at the front, they'll be left out. It's very sad. I need to find a way to maybe minimize that, some other mechanism. Right now it's just raw evolution, and every entity that is not kind of new will just get worse and worse over time, and most of them just phase out. Either get struck out or get limited. Well, not many of them get struck out, but still, a lot more of them get limited. Because being struck out means that you somehow went up in terms of some utility values. Because having more constraint, having higher sum of constraint values means that you probably have a higher sum of utility values, which can be seen here. See, these were the entities that were struck out, and compared to this, you do see some entities have some upward slopes until they got struck out. Yeah, and this is the world. See how every entity, even in the final state of the world, have a downward slope. This is because none of them got struck out. They were yet to be struck out, or yet to be limited. But all of them were like this, which is sad. I don't really see many. I don't really see a lot of entities, constantly going up or becoming better. We'll see that in a moment. Let's go to world. And we can have a look at this for now. Let's see, limited. When did this start? 3:23. It took 9 minutes on my MacBook, so it should take about 27 minutes. 3:93. Now the time is. Oh, I still have 22 minutes. Oh. I wonder if I can actually fill that time. So anyway, let's have a look at these. This is from the world. Well, this is from the final state of the world, and the entities, the plots here are in alphabetical order, so let's just keep that in mind. So some entities do show this, this pattern, or they just kind of stay and go in a horizontal manner, but a lot more of them just slope downwards. Like for example, this one and this one stayed almost the same for 1, 2, 3, 4, 5, 6 generations, which is kind of rare. This one also stayed at about the same level. Well, not that much of a difference over 9 generations. But the sad thing is, if they fall, they never actually recover. Because once you're at the top, the only way is down. See, they all go down. And this is sad. Well, but it's also, if you think about it, the way the evolution scheme works, this is expected. Because you either just mutate, which means that you'll probably lose in terms of some utility value, and if you go any higher than this, you would go over the threshold, because if you're already this high up, it means that you're very close to the maximum constraint, the threshold, and you will very likely go over and then get selected and struck out. So that's what happens. Enough of this one. Let's go to struck out, because there are only 2,000 of them. Now here, we see more entities that have some other kinds of slopes. They can sometimes also stay the same, and then, for example, this one and this one, these two entities stayed the same for generation 60 and generation 61 and generation 49 to generation 51. So they stayed the same, but the moment they mutated, because the only way they can change this mutation, when they mutated,
the some gene got activated, and that added onto the constraint summed constraint value, and then the summed constraint value went over the maximum constraint, and then it got struck out. Same for this. Same for this. Same for this one as well. So something got added here, and then it just went all the way up. Well, actually, the last one, the last state of the chromosome, if we calculate the summed constraint value for that, it will go over the threshold because I made it that way. So if I run more on this, I would see that I could probably see what got added and then and caused it to go over the maximum constraint threshold. But yeah, we do see more entities with slopes that are sometimes going up with positive slopes, for example this one. But these entities are kind of short-lived, as you can see. They rarely go over, they rarely exist over 10 generations. The lifespan. And as soon as I said that, this one kind of lived more than, what, 35 or 40 generations? For 40 generations? And then when this happened, when the last upward movement happened, it went over the threshold and then got selected out, struck out. It was doing so good for about 40 generations. Similar for this. It lasted about 25, 30 generations, and then it went over the threshold. Also same here. This got struck out at during the last generation, and it lasted for about 43. Well, 43 generations. Not about. It lasted for exactly 43 generations. This one was, coming back up, and then it got struck out. This one was also doing that, and then it got struck out. Well, looking at these plots do give me, some hope. But I know that when this notebook finishes saving all the plots for the limited out entities, I know I'll be very depressed. Well, kind of depressed. Ooh, look at that. we're in the D's now. Speed this up. Let's start from the very end. It won't make any difference, but or I could just do yep, that and huh? I can just sort these plots by the time they were created. Let's have a look. I don't think this is working. Yeah. Nope. I don't think it worked. Like, what happened here? It wasn't doing so well, but this caused it to get struck out. This thing existed for such a long time, for about 90 generations. And then that one last addition just caused it to go over the threshold. Same thing here, about 60, more than 60 generations. Oh, great.
It finished. Cool. How long did it take? 3:41. 18 minutes. So this took twice as much. So not always 3 times slower. So now we look at the more depressing set of plots. And yeah, let's have a look. And we'll see that all these plots have a downward slope. See, none of them actually have an upward slope, an overall upward slope. Maybe this one. But then again, I think it was just unlucky and it got limited out because its sum utility was so low to start with, and it was born in generation 3. And usually when you're born early, you will have lower sum utility values, and that's a big no-no. See, all of them are just going down and down and down and down. See, these were also very interesting bumps, but they go down nonetheless, because I think that they're not actually given enough time, or there are no mechanisms for them to change other than through mutation. And this one, like it started from such a low sum utility value, and then it did get better, it did improve. But while it improved for about 60 something generations, so many entities got added. So many newborn entities got added at the front of the world. And gradually this got pushed towards the end, and then it just got limited out. We're still in the A's. Let's have a look at something in the middle, because there are like 12,000 entities. See, still very sad. So here's the take. Here's my take. So far, up until now, I've only been focusing on how to make the sum utility value go up and plateau at a reasonable level, and how to minimize the dips at the cost of sacrificing entities with low sum utility values. But that's all very the way I see it, or I think what I've been doing was very collective, as in I focused on the overall scores. Scores or metrics, and some things like some utility values, and mostly that, and maybe peak, plateau. Still very hard to spell plateau, etc., etc. And also the distribution of entities. But when I look at this, I did this by using the through ranking the entities, and then through procreation, which added a lot of innovation, or which improved the overall scores or metrics, which improved these. But at the same time, I wasn't actually paying attention to each of these, well, I wasn't paying any attention to any one of these entities, even the ones that got, that remained in the final state of the world. I didn't pay any kind of attention. So now I think would be a good time to start making this shift and find a balance where I could ensure that entities I should ensure that entities on an individual level can improve. Because if this happens, if this keeps on happening, it's almost like aging. And then you age and you die. But which you can argue, which people may argue that that's a very natural thing, to happen. But it is a problem if so many of the entities with age just wither. Just, they don't improve ever. And that's very sad. There needs to be, so therefore there needs to be some other mechanism to ensure learning or learning or mimicking. How do you spell mimicking? Is that it? I think that's it. Mimicking, or just, anything for this, for example, for this entity, Charlotte Khalid, to start from there, and then, although it fell down a bit, a way for this entity to make, or make some choices so that it can go back up, so that it can maybe recover, or maybe even just go above and beyond than how it used to be. Not this depressing downward slope. See, all of these are very depressing, very, very sad. So so that some a mechanism to do that, so that when an entity is introduced, for example somewhere here, it might fall down a bit, but then it can just come back up, and then fall back down, and then constantly keep going back up, and then maybe fall down again, and then maybe come back up, stay there, fall down, and come back up, something like that. This is what I want. Or something like this. Or something like this. Or sometimes just go down and then just get limited out. But I do not see anything that is like that. Any graph, any plots, any lines that do this. Because any entity that had, or that has high sum utility value, they got it from the start because their parents were very good. But even these parents died, or they either they went down in some utility values, and then eventually they would get limited out, or something happened and then they get struck out. So this is sad. these entities, these two entities, made an offspring which gave the newborn a very high sum utility value, but then this also came down. And then it would get left out, or it just go over the threshold and just get struck out. So that's sad. That's very, very sad. I don't want that. Well, these two things are happening too much. Yeah. So I need to find a way to do that. Because on a personal level, I think seeing all these lines going downwards is just terrible. You know, it's almost as if there's no purpose of life. So that's very sad. And to do that, I need to start looking at things from, well, I need to change my perspective. So far it has been on a collective standpoint. Now things need to be at a more individual level, because I'm not doing this to to merely generate just to generate good, best solutions. I'm doing this to generate happy or worthy entities. There's a difference. Where did my thing go? Oh my god. I'm so bad at this. I'm not doing this to generate good, bad, best solutions. I'm doing this to create happy, worthy? I don't like that word. Just happy entities. Just let's just say entities for now. Entities that can, or rather that may be able to feel happy, or feel the self-worth, some self-esteem, whatever, or just the reason to exist, a reason to exist. This is what I've been doing so far, and that's a no-no. I need to start doing this. That's a typo. And these two, I think, are very different things. Okay, that's about it. Well, wow, 74 minutes, holy shit. Thanks for watching. See you next time. Bye.